Hey everyone, we're going to kind of do a review of relationship angles with angles, and then kind of do a lot of problems with the working with the algebra with angle relationships and solving for x's and finding angle measures, but tying it all into all the relationships we talked about on Friday and yesterday with the alternate interior angles, the corresponding angles, supplementary angles, complementary angles, vertical angles, things like that, just to make sure we understand how to do all these problems that arise a lot in geometry. So for the review, here are the list of the angle relationships we talked about over the last few days. We have complementary angles, supplementary angles, vertical angles, what a linear pair is, corresponding angles, interior and exterior angles, alternate interior and exterior angles, and then consecutive interior angles, which I'm going to introduce a new way they're called today. A little bit simpler to remember, I think. So we'll go through there. So complementary angles, we remember that those are angles that add up to 90 degrees, something that we should always try to remember. Supplementary angles, those are the angles that add up to 180. Vertical angles are the opposite angles formed by lines that cross. So they're going to share a vertex, but they're not going to share any sides. We have to remember that these angles are congruent. I'll kind of write notes like that as well. So they're congruent angles. Linear pair angles are two adjacent angles that are on a straight line. So they share the ray that comes off the line. The other sides of both angles is that straight line. So they're adjacent. They form a straight line. These angles here are supplementary. Oops. Supplementary. Corresponding angles, they're angles formed by a transversal cutting two lines. And remember, those angles are in a similar position to the two lines. They're on the same side of the transversal. They're on the same top or bottom side of the cut line, or so they're in like the same position. Those angles, again, these are congruent as well. Interior angles, these are the angles that are between the two lines that are cut by the transversal. So usually there are going to be four of them. They are between the two lines, and then there are relationships depending on what they are inside that line. The exterior angles, those are the angles that are on the outside of the lines that are cut by the transversal. Alternate interior angles, these are interior angles. They're on opposite sides of the transversal. As with the transversal comes down, they're going to be on opposite sides. These here are also going to be congruent. Alternate exterior angles, they're the angles that are on the outside of the lines cut by the transversal, but they're on opposite sides of the transversal. Again, these are as congruent as well. And then the consecutive interior angles, we're also going to start calling them, we're going to hopefully be able to pull this off and start calling them same side interior. Because that's really what they are. They're on the same side of the transversal inside the two lines. So calling them same side interior, I think it helps out. But there again, they're the angles that are between the lines on the same side of the transversal. And these here are supplementary. They are going to add up to 180 degrees. So is that, everybody kind of remembers that? We're going forward here. Okay. So 2 examples. We have angles 4 and angle 13. I want you to use the diagram on the right and come up with one angle that identifies the relationship with angle 4. So what angle is a vertical angle to angle 4? What angle is supplementary to angle 4? If you can name all the angles supplementary to angle 4, awesome, but try to do the best you can. I want at least one. So do that for angle 4, the top, and angle 13 on the bottom, and see how you did. Enter. We're going to have you entering your answers in the Ed puzzle, and then come back and check and see how you did. Okay, so as we go through, the vertical angles for angle 4 is angle 2. Supplementary angles would have been 1, 3, or 5. There may be some more if you could find them. I just went with those 3. Alternate interior angles are angle 6. Alternate exterior angle was angle 10 because angle 4 is its interior on lines M and N but it's exterior when we're looking at lines P and Q. Whoops, sorry, wrong way. And then consecutive angles, that's just angle 5. For angle 13, the vertical angle with angle 13 was angle 15. There is only one. Vertical angles are only a pair. Supplementary to angle 13 could have been angle 14, angle 16, angle 12, or angle 6. Alternate interior angles could have been either angle 11 or angle 7. Alternate exterior angles, that was not possible because 13 is definitely in between both pairs of lines. And then consecutive angles would have been either, so the same side interior would have been either angle 12 or angle 6. Hope everybody got those. All right, moving on. Examples of working with algebra to solve for angle measurements and variables. Is a big chunk of what we're going to kind of finish up this unit on. Hopefully we kind of see how to do it. There'll be a lot of stuff we'll be doing with triangle work with algebra that kind of ties into this. So we want to find the value of each variable. We have x's and y's in our equations. What we need to do is we need to identify the relationships between these angles. So what I'm going to do quickly here, just to kind of help us through the problem, is I'm going to call this angle 1, I'm going to call this angle 2, and I'm going to call this angle 3. So as we're looking, we have the 3 lines cut by a transversal. The 3 lines are all parallel. So that tells us right away that the relationships, we're either going to have supplementary angles or we're going to have congruent angles with our relationship. We just have to figure out what the relationship is. So if we look and see, what we have is corresponding angles between angles 2 and 3. They're corresponding angles. Angle 1 and angle 2 don't have a readily available relationship. But what I can do is I'm going to name another angle here quickly. I'm going to call this angle 4 to help us out, help me show you what's happening. I know angle 1 and angle 4 are a linear pair. So angle 1 plus angle 4 is going to equal 180 degrees. They're going to be supplementary. Does everybody see that? From that there as well, I see that angle 4 and angle 2 are alternate exterior angles. Does that make sense? Because they're outside the lines. I'm looking at these lines being parallel that I just marked with the red. Angle 4 and angle 2 are outside those lines on opposite sides of the transversal, makes them alternate exterior angles. That tells me they're congruent. So because they're congruent, and I know 1 and 4 add up to 180, that's going to make 1 and 2 have to add up to 180. So that's where we're going to start our problem. Angle 1 plus angle 2 equals 180 degrees. I look and I see my equations. So I got 5y minus 4 plus 3y is going to equal 180. I add some stuff up, combine my like terms. I get 8y minus 4 equals 180. We have to move 4, so we're going to add 4 to both sides. I have 8y now equals 184. You divide by 8, end up with y equals 23. So I've found y. I know now y is 23 degrees. How does that help me find x now? Well, now I look and see that angle 2 and angle 3 are corresponding angles. Again, they're congruent because corresponding angles are congruent. So I can set 2x plus 13 equal to 3y, but I know 3y now is 3 times 23. So really my equation here is going to be 2x plus 13 equals 3 times 23, or 69. So I end up with 2x plus 13 equals 69. I subtract 13 from both sides. And with 2x equals 56. So x now equals 28. And I've solved for each variable. Does that make sense? You have to kind of look at the diagram. Where do my lines, where do my angles lay out in relationship to the other angles? you may have to bring in angles that we don't have any information for. We didn't have any information for angle 4, but I needed angle 4 to identify the relationship between angle 1 and angle 2. Does that make sense? Okay. So on the next page is what I want you to try. It's a similar problem. It's just two lines this time. So kind of look at the relationship, solve for both variables, and enter them into Edpuzzle, then come back and see how you did. Okay, so here's the work you should have done. I kind of did the same thing. I identified my angles as 1, 2, and 3, so I could start and figure out what's happening. I knew angle 2 and angle 3 were supplementary because they were a linear pair. Problem is they're two different variables, so I have to create another type of relationship so that I can get the same variable in an equation. So that's where I went with angle 1 and angle 3 being alternate exterior angles. That again allowed me to say that angle 1 and angle 2 are supplementary, because if 2 is supplementary to 3 and 3 is equal to 1, then 2 is supplementary to 1. Make sense? Because they're congruent, they have the same measurements. So if they add up to 180 with angle 2, then angle 1 is going to be the same because they're the same measurement. So I set those equal to each other. I found out x was 14. I plugged that back in now. I was able to determine that angle 2 was 42 degrees. So angle 3 then, 4y minus 10 plus 42 had to equal 180. I solved that through and I got 37. Hope everybody was able to do that. Okay. Again, I want you to try this one. It's a little bit of a trickier problem. Kind of go through, see how you can do. Again, identify your relationships. We have the diagram. The diagram is going to be used for both pictures, but we're solving for both questions, but we're solving each question independently. So just because you solve for a measurement in angle 10 in the first one, that's not the measurement we're using in the second one. We have to completely solve a new equation. But you have all your information. Try to figure it out and enter your answers in the Edpuzzle, then come back and check and see how you did. Okay, a lot of work, kind of squeezed it in. I tried to identify different colors here, hopefully it worked. Again, I know angle 1 and angle 2 are supplementary. They're a linear pair, so they add up to 180. I created my equation. I solved through and I found x equaled 24. So what I can do then is I can plug in x equals 24 into 3x minus 13, because that tells me what angle 1 measures, and I found out angle 1 was 59 degrees. I look and see angle 1 and angle 10 are alternate exterior angles. So that means they're both the same measurement. So that tells me angle 10 was 59 degrees in the first one. The second one, I'm looking again. I'm trying to figure out what the relationships are. I know angle 6 and angle 10 are supplementary, because 6 is supplementary to angle 12. 12 and 10 are corresponding angles, so they're congruent, so 6 can be supplementary to angle 10. That gets my equations with x's in it for the first problem. I go through and solve that for x equals 22. I plug that in now to find out what angle 12 needs to be, or y needs to be, because I know now angle 12 is going to equal 32 degrees because angle 6 is 148. When I kind of kick through that and solve that out, I end up finding out y is actually 47 over 3, which is a really weird equation, but that's the answer. So y was 47 over 3, and the angles are 148 for 6, and then 10 and 12 are both 32. That makes sense. Was everybody able to get that? Again, if you didn't get it, when you guys come in on Thursday, we'll kind of go over it again just to make sure. I want to make sure that we understand this part of it. I know this is a little bit of a struggle learning it at home, where I'm not there to help you specifically as you're working on the problems. Okay. Here we're working with complementary, supplementary stuff with perpendicular lines and kind of tying in with that rather than the full-on transversal stuff. So it gets a little bit easier because we're pretty much specified into what we're looking at as we look at our equation. So in this example, we're solving for y and finding the measurements of the two angles. We see that we have perpendicular lines to put the right angle box. So that tells me all 4 of those angles are 90 degrees, which tells me my 2 angles with the measurements there have to equal 90. So it's just a simple matter of 4y minus 5 plus 2y plus 5 equals 90 degrees. We'll combine our like terms. Plus 5 minus 5, they disappear. So I end up with 6y equals 90. We divide both sides by 6. I end up with y equals 15. So we've answered a third of our question. We've solved for y. Now I'm just plugging y back in. 2 times 15 plus 5 is 35 for this angle. 4 times 15 minus 5 is 55 for that angle. Does that make sense? Everybody see that? Okay. Here's one for you to try. Again, plug your answer in Ed Puzzle. Come back and check your work. All right, so again, we see the 2 angles have to add up to 90. They tell us it's 90 degrees. So 9x plus 5 plus 3x plus 1 equals 90. Combine our like terms, move 6 to the other side. We find out x equals 7. Plug 7 back into our equations for those 2 angles. We find out the big angle is 68 degrees. The smaller angle is 22. Does that make sense to everyone? Okay. Again, a couple more for you to try. Want you to plug your answers in a puzzle, find values of x and y, then come back and check your work. All right, so the easy question was MSN is 90 because it's the angle. They actually, it's this angle here that they've identified as the right angle box. So you know right away that's 90 degrees. So number 2 is piece of cake. Number 1, we're going to set each of those equal to 90. So the first one is 9y plus 18 has to equal 90. So that was simply 8. Y equals 8. The other one is 5x plus x equals 90. So it's 6x equals 90. So we can x is 15. That makes sense? Everybody seeing this? Okay. I believe these are the last 2 I want you to try. Little trickier. Read the question, see what they're telling you, and see if you can figure it out. The second one we're trying to solve to make those 2 lines perpendicular. They're not telling you they're perpendicular. We want to find a value for y that makes them perpendicular, so you have to remember what that means. All right, so let's check our work. The first one, they told you that BD and BF were perpendicular. So you kind of draw in the box there from BD and BF. So that tells us that x plus 3x plus 10 equal 90. We solve through, we find out x equaled 20. We then go through, and I've changed color for the blue. We're looking at EFB and FBC. We're trying to find a value for y to make the angle that those 2 angles form a 90-degree angle, to make EB perpendicular to BC. So we did that by setting them equal to 90. We solve for y. We find out if y is 9, those 2 lines are perpendicular. Does that make sense? Does everybody see that? Okay. So that is the end of our video. There is some work out on Google Classroom. I want you to try those problems, see how you do for homework. And I will talk to all of you tomorrow for the half day. Tomorrow's class is just going to be, again, it's the Wednesday quiz thing, the new thing we're doing, at least until April 26th. So I think it's just going to be a Kahoot, a fun little trivia contest. We're going to try to do that for extra credit points that will be added to your overall term grade. Not term grade, your overall point total. When I add all the points up at the end of the term, I'm going to give you probably 5 or 10 extra credit points, depending on how well you do on this trivia thing tomorrow. That'll get added to your total to help boost your score if anybody needs it. I'm not just adding it, figuring out your grade and adding 10. I'm going to put the 10 in before I figure out your grade, if that makes sense. Again, I can go over that when you come in if you have any questions. So have a good day. I will talk to you tomorrow.